We call these equations involving your inverse trig functions. Now notice with this first example, they don't want you to actually solve it for x in terms of x equals these angles. They simply want, you remember taking like in algebra, I gave you the formula for converting Fahrenheit to Celsius, and they wanted the other one where you had to take the equation, solve it for some variable. So instead of solving it for F, you had to solve it for C. They simply want you to take this equation and solve it for x. So we have y equals 3 cosine 2x. Let's get the cosine 2x part alone. So we'll divide both sides by 3. So we have cosine 2x equals y over 3. Okay? And then here's what's meant by the title of this section. You are going to turn around and take the inverse cosine of both sides. Take the inverse cosine. Because what happens on the left? Cosine and inverse cosine cancel each other out. They're inverse functions of each other. What are we left with? We're left with 2x. So we have 2x equals inverse cosine y over 3. And they want us to solve this equation for x, so I'm going to divide both sides by 2, and I'll finish. So x is equal to inverse cosine y over 3, all of that over 2. And that's all they wanted you to do with that problem. That's the only one that we look at that's like that, where you don't actually end up with some type of numerical solution. All right? So that's kind of like the groundwork for the next couple of problems. You're going to end up simply taking the inverse function of both sides. Next example. Solve 2 arcsine x equals pi. We'll begin by getting arcsine x alone. So let's divide both sides of the equation by 2. So we have arc sine x is pi over 2. And now we'll take the sine of both sides. Take the sine of both sides. What happens on the left? Sine and arcsine. It's just like taking square and square root, right? Take x, square it, turn around, take the square root. You're back at x again. Here we're taking x, arcsine of x, turn around, take the sine of that, you're back to x again. They cancel each other out. And the sine of pi over 2 is? Oh, you're getting, I don't want the angle. I want the sine of pi over 2. 1. There's your answer. Sine of 90. Questions so far? They get more interesting. Hold on. Here's a problem where we have two different trig functions, same equation. And again, what would you do to both sides if you wanted to get x by itself? Right now, what would you do to both sides?
Divide by cosine.
No, that's not multiplication.
Yeah, take the cosine.
Take the cosine of both sides. Good. That is going to give us x equals the cosine of arcsine of 1/2. And the right-hand side of this equation you've already done in previous problems. Remember, this is just simply an angle. Right here, this is an angle. Arcsine 1/2, that's an angle. Whatever it ends up being is whatever it ends up being. And then we're going to turn around and take the cosine of that angle. Remember that arcsine is a function that gives you an answer that must be in either quadrants 1 or 4. It's 1 because it's 1/2. We got lucky here. This ends up being a nice angle, right? So what is the angle that has a sine of 1/2? 30 degrees. This one's probably dealing with radians. So we're going to write this as pi over 6. So this is nothing more than the cosine of pi over 6. And the cosine of pi over 6, square root of 3 over 2. You always have the ability, and you should get in the habit of, just like in algebra, if you want to leave this problem knowing that you got the right answer, right? Not guessing if you got the right answer, plug this back in the original. If you take the root 3 over 2 solution, substitute it in right here and just there. Shouldn't I thought it was more than one place. Put it right there, and it should make that a true statement, and it does. Okay. One more page, and they get more interesting. Example 4, last page. Oh my word, it's the only problem on this page. Will I have to fill up all of this space with work? Probably. This is the worst case scenario. You ready? You're going to use that whole white space, I guarantee you. Depends on how big you write. What you would like to do here, notice that we have arc sine and also arc cosine. And you know, if you take the sine of both sides, you're going to knock out one but not the other. If you take the cosine of both sides, you're going to knock out one and not the other. So you just have to pick one to start with. So I like having positive coefficients. So I'm going to go ahead and take the negative arc cosine x to the other side. So we have arc sine x equals pi over 6 plus arc cosine x. Okay? Now to get x by itself, on the left that is, let's take the sine of both sides. Let's take the sine of the left and sine of the right. I'll do the left.
I'm generous with you.
Yeah. You can see what happens on the left. Sine and arc sine cancel each other out and you're left with x. Guys, what do we have on the right-hand side? We have the sine of, this is an angle right here, guys, right? Arc cosine x is an angle. So you got the sine of a sum. Sine of a sum. The sine of a plus b is sine a cosine b plus sine b cosine a. That's what we're going to use on the right-hand side. A will be like pi over 6, and my angle B is this arc cosine x. So writing that out, then we're going to worry about what each individual piece is. Writing it out, we're going to have sine A, or sine pi over 6, cosine B, cosine arc cosine, oh that's nice, cosine arc cosine x, we got that one, that's easy, plus sine of arc cosine x. That one's the nasty one. Times cosine A or cosine pi over 6. That one's not bad at all. Did I lose anybody with me? See how we're using the sine of a sum identity? All of these are going to knock out and be easy to follow except for the one that we need to worry about. And that's what the rest of the piece of paper is for, to worry about the one we don't know how to do. So clean this up a little bit. We have x equals, the sine of pi over 6 is 1/2. And cosine arc cosine x is x plus, on the other hand side, let's do the easy one. The cosine of pi over 6 is square root of 3 over 2 times, have no freaking clue right now. Right? We're going to ask ourselves, what is the sine of arc cosine x? Right? So let's just take a look at that for a minute. What is the sine of arc cosine x? What does this mean to you guys? Arc cosine x simply means there's an angle out there whose cosine is x, right? So if I look at quadrant 1, why am I picking quadrant 1? Because it's positive x. If I look at quadrant 1, how can I describe an angle whose cosine, whose x over r, right, whose horizontal over radius is equal to x? You can make it x over 1. Right? Whatever this angle is, whatever that is, do you see how it would have right now a cosine of x? If I label the horizontal component x, if I label the hypotenuse 1, that angle has a cosine of x, right? Now I'm going to turn around and take the sine of this angle. Well, I'm missing this piece from here to here. And if I use Pythagorean theorem, what am I going to get? I'm going to get, no, not for the,
some kind of x.
It's going to be an expression of x. So it's going to be 1 squared minus x squared, take the square root. There's my expression for the y component, the vertical component. So what's the sine of this angle then? The sine of this angle, whatever it is y over r. R is still 1, so it's just the square root of 1 minus x squared.
Can x squared cancel out?
No, squaring the square root does not. Right there is what we need to fill in our last parenthesis with. Going back to the problem, last parenthesis is now the square root of 1 minus x squared. I gotta pause there because that's the hard part about this problem. Do you know where that's coming from? The square root of 1 minus x squared? Because the rest is algebra. The rest of this is algebra. Let's go ahead and multiply together and see what happens. Do you see how, I'm going to skip a step here. Here we have 1/2 x, right? 1/2 x. Let's subtract that from both sides. I have 1x on the left. 1x minus 1/2 x is 1/2 x. So we have x over 2 on the left. And on the right-hand side, we have root 3 over 2 times the square root of 1 minus x squared. I don't like all of these radicals right now. Let's square both sides of the equation. On the left, if we square a fraction, we square the top and square the bottom, and we get x squared over 4. Over on the right-hand side, right, we're going to square that. We're going to square this. And we're squaring a product. A product. We're not squaring a sum or a difference. There is no FOIL here. There is no square the first, square the last, multiply, it's a product. So all we got to do is square that and also square this. So we end up with 3 over 4 times 1 minus x squared. So what do we want to do next? Let's multiply both sides by 4. Get rid of the fractions. Now we're down to x squared equals 3 times the quantity 1 minus x squared. Distribute the 3 through. 3 minus 3x squared. Add 3x squareds to both sides. We get 4x squared equals 3. Divide both sides by 4. We get x squared is equal to 3/4. And now we take the square root of both sides. X is equal to plus or minus the square root of 3 over 4. And we can rationalize the denominator and write this as plus or minus the square root of 3 over 2. At this point, we have 2 possible answers. Please do not go through all this work and not check your 2 answers. Do you remember in algebra we have what were called extraneous solutions, where You've made no mistake with your algebra. You came up with two answers, but when you plug them back in, they may or may not work. Well, we got to kick the negative one out. I'll tell you right now, the negative answer does not work, and there is only one. It's the positive root 3 over 2. That is worst case scenario of a problem. You can see how it could quickly fill up a whole piece of paper. That may be an extra credit question on the exam. Who knows? Question, Josh?
No.
We all good?